Hello guys. So in the previous lecture, we what we did is we saw how this min-heapify function works. But in this lecture, we are going to code this function, okay, on the Visual Studio Code, and we are going to test the output, whether we are getting the correct output or not. Okay. So let's take this example only, okay, that we did in the last lecture. Okay. Let's zoom it a little bit. So the input, okay, so the input is going to be something like this. Okay, so input is going to be something like this. Okay, so heap has 40 at the first index, then 20 at the second index, 30 at the third index, 35 at the fourth index, and 25 at the fifth index. Okay, the output that we should receive after performing the min-heapify function is going to be this, right? So 20 comes at the 0 index, 25 at first, 30 at second, 35 at third, and 40 at fourth. Okay, now let's try to code this. Okay, so let's get back to the Visual Studio Code and let's write the code. Okay, so let's say we call it min-heapify. Okay, heapify. Okay, let's write the boilerplate code. Okay, so why don't we copy the whole code? Okay, so yeah, so let's copy this. Okay, let's copy this. So let's paste it here. Okay, yeah, now we already, let's remove the rest part. Okay, yeah, so we already have this much of thing, so we just have to implement the min-heapify, okay, function to correct, okay, the position of the min heap. Okay, min heap. Okay, now what we'll do, okay, void min-heapify. This is going to be a void function, right? Int of I. Okay, so what we'll do, int left is equals to left. Okay, left, int L is equals to left of I, right? Int right becomes right of I. Int smallest becomes I itself. Okay, so for not for, actually, if left is less than size and ARR of left is less than ARR of smallest. Okay, smallest, not greater. Yeah, ARR of left. So smallest becomes left. Okay, now again, if R is less than size and ARR of R is less than ARR of smallest. Okay, smallest becomes R itself. Okay, now finally we'll check for the condition. If smallest does not equals to I, the value that we pass in the parameter, then we'll swap, okay, ARR of I with ARR of smallest. Okay, and we'll call the min-heapify function for the smallest. Okay, now this is going to be the code. Okay, now let's give the input. Okay, so let's create the min heap. So we'll create heap. Okay, heap m, let's say, having the size 5. Okay, now let's get back, let's check the input. So 40, 20, 30, 35, and 25. Okay, so m dot ARR of 0, let's say it becomes 40. Okay, then let's copy this. Okay, so let's check again. 40, 20, 35, 30, 35, 25. Okay, so this is 20, this is 30. Okay, this is 35, and this is 25. Okay, that's it. Now after inserting all these elements, the size becomes m dot size becomes 5, right? M dot size equals to 5. Okay, let's assign the size as well. Now what we are going to do is that we are going to call min-heapify function. Okay, min-heapify, m dot min-heapify. Okay, because yeah, m dot min-heapify of 0, right? We have to change the the value at index 0, right? That's 40. Okay, now the output that we are going to receive is this 20, 25, 30, 35, 40. Okay, so for int for int I equals to 0, I is less than num dot size. Okay, I plus plus. Okay, okay, this is not going to be the function. Okay, either you can write it m dot size or m dot capacity, both will be fine. Okay, because I've incremented the size, right? Now we are going to print m dot arr of I. Okay, let's see what we get as the output. So let's put some spaces in between, right? So let's check. Okay, so yeah, so I one thing I did wrong is the indexing. Okay, 3 and this should be 4, right? Yeah, now let's check again. Okay, so we get this 20, 25, 30, 35, 40. Let's see, 20, 25, 30, 35, 40. So the output is correct, hence this is the correct min-heapify function. Okay, now the second thing that we're going to talk about is max-heapify function here. Okay, so let's expand this. Okay, let's move it a little bit. Okay, yeah, so in this lecture we are going to talk about the max-heapify function. Okay, so in the previous lecture we talked about an example, right? In this lecture we are going to look at another example. Okay, so let's suppose we have a max heap here. Okay, we are having a max heap here of size 5. Okay, let's suppose the size at the top is, let's say it is 30 here. Okay, it's 40 here, then it is let's say 35 here. Okay, now let's say the childs are 25, and let's say this is this child is, let's say 35. Okay, not 35, 36, let's say. Okay, now let's say this is the max heap. Okay, I equals to 0, this index will be 0, right? This will be 1, this will be 2, this will be 3, and this will be 4. Okay, so I already told you the code, but let's write it again. Okay, so talking about the code. Okay, so it will be a void function, right? Void max-heapify. Okay, void max-heapify. Okay, int I will pass in the parameter the index that we have to fix. Here we'll pass 0 because the top should have the maximum value, which is 40. Okay, obviously, and then 36 should come here, and then 30 should be at this position, index 4. Okay, so after performing max-heapify, on this heap. Okay, max-heapify of 0, because that's what the value at that index should be fixed, right? So the new max heap that we are going to obtain is going to be something like this. Okay, so this and this. Okay, the value here should be 40 at index I equals to 0, this is I equals to 1, this is I equals to 2, this is I equals to 3, and this is I equals to 4. Okay, the value at index 1 should be 36, the value at index 4 will be 30, the value at index 3 will be 25, and this will be 35 only. So this is the max heap that we are going to obtain. Okay, this is the final max heap. Okay, final max heap. Okay, yeah. So what is the how is the function going to look? So int L is equals to left of I. Okay, int I is, sorry, not I actually. Okay, this is going to be R, and R is going to be right of I. R is going to store the right of I. Okay, now instead of smallest here we'll take the largest, because we have to make changes with the largest, right? I. Okay, now there will be two conditions again. If left is less than size and ARR of left is greater than ARR of largest. Okay, largest, then in that case largest becomes L itself. Okay, this is the first condition. The second condition that we have to check, okay, is if right is less than size and ARR of R is less than, sorry, it should be greater than, right, is greater than ARR of largest. Okay, then in that case largest becomes R. Okay, R becomes the largest. Okay, now we will check for the last condition, which is if okay, not smallest. Okay, you have to remember this. If largest is not equals to the initial value, the initial index, will perform the swap. Okay, swap ARR of I with ARR of largest, and what else, we will call max-heapify for the index stored in the largest. Okay, largest. Okay, let's move it a little bit. Okay, we'll call max-heapify for this index. Okay, which is stored in the largest variable. So this is how this function is going to look like. Okay, now let's see how it works. Okay, now let's move it. Okay, yeah. So in the context of the heap that we have taken, okay, this heap, let's see how it works. Okay, so let's create the array for this heap. Okay, let's create the array for this heap. Okay, now the array would look something like this. Okay, so let's suppose this is the array. Okay, it will have 5 blocks. Okay, this is 0, this is 1, this is 2, this is 3, and this is 4. Okay, all the this is array, right, ARR, and it is having size equals to 5. Okay, because 5 elements are there, right? So the first element, initially we are taking the initial thing. Okay, so 30 will be there, 40 will be at index 1, at index 2 35, at index 3 25, and at index 4 36. Okay, now this is what it is going to look like finally. Okay, but we are going to dry run the code on this array, right, and the heap will look like this initially. Okay, so the heap will look like this. Okay, so let me create the heap. Okay, so this will be the heap. Okay, let me write the indexes as well. I equals to 0, I equals to 1, I equals to 2, I equals to 3, and I equals to 4. Okay, let's just not place the elements till now. Okay, now let's try run the code. Okay, so from the start. Okay, so okay, let's just fill the elements as well. So here at the first index, okay, let's just undo it. Okay, let's just change the color. Okay, yeah, so the first index will have element 30, then at first index the element will be 40, then 35, and then 25 here at index 3, at index 4 it will be 36. Okay, so this is what the heap looks like initially. Now what we'll do, according to the code. Okay, so L is left of, first we'll find the left. Okay, so now finding the left. Okay, so left is initially, let's say we call the function, let's erase this. Okay, let's say we passed I equals to 0, because at 0 the change should be there, right? 40 should come at index 0. Okay, so violation is at the root itself, so we'll give I equals to 0. Okay, now what do we get? So left becomes 2 into I plus 1, which is 1 itself, because I is 0, right? Right becomes 2 into I plus 2. These are the formulas, right? So right is 2 now. Okay, now we'll store I in the largest. Okay, so largest becomes equal to I 0, right? Okay, now we'll check for the first condition. So if whether L is less than size, so 1, size is 5, right? Size is 5. Okay, we have to remember this, size is 5, right? 5 elements in the heap. Okay, here also I've written this. So size is 5. So AR, whether left, which is 1, is less than 5. Yeah, so this condition satisfies. Now testing the second condition. So whether ARR of left is 1, is greater than ARR of largest is 0. Okay, so let's see, ARR of 1 is 40, ARR of 1 is 40, right? So whether 40 is greater than ARR of 0. Okay, ARR of 0 is 30. Yeah, so this condition is true. Okay, so largest becomes L, so largest becomes 1 now. Okay, it becomes 1. Now again checking the second condition, R is less than size. R is 2. 2 is obviously less than size, right? Size is 5. Now we'll check whether ARR of 2, R, right? ARR of 2 is greater than ARR of largest. Largest is 1 now, right? So let's check. ARR of 2 is 35. Whether it is greater than ARR of 1. ARR of 1 is ARR of 1 is 40. Whether it is greater than 40? No. So this condition is false. Hence the largest is 1 now. Okay. Now moving on to the final condition. If largest is not equal to I. So I was 0 initially, right? And largest has become 1 now. So largest is not equal to I, definitely. So this condition satisfies. So swap ARR of I. ARR of I is ARR of 0 and ARR of 1. Largest, right? Largest is 1. So we'll have to swap this thing at these 0 and 1 index. So we have to swap these two values. Okay. So upon swapping, what do we get? 40 moves to index 0. Okay. 40 comes here and 30 moves to index 1. Okay. Now again, erase all this. Okay. Let's erase all this. Okay. Now the value of largest has become 1. Okay. Let's erase all of this. So yeah. Okay. Now again, for 1 we are going to check. Okay. So now after swapping we'll call the max-heapify for the largest. Okay. So we'll call max-heapify of largest is 1. Okay. So by this calling, what we'll get? Okay. So we have passed I as 1 now. Okay. So the value of I is 1 now. Okay. And if the value of I is 1, left becomes 2 into I plus 1, which is 2 into 1 plus 1, which is 3. Right becomes 2 into I plus 2, which is 2 into 1 plus 2, that is 4. Okay. And largest becomes the value that is passed in the parameter. So I itself. Okay. 1. Okay. Now we will check. We'll check for these two conditions, and then we'll check for the final condition. So we'll check again whether the left is less than size. 3 is less than 5, right? Size is 5. So 3 is less than 5. First condition satisfied. Second condition, ARR of whether 3 ARR of 3 is greater than ARR of largest. ARR of 1. Okay. So let's check. ARR of 3 is 25. Whether 25 is greater than ARR of 1, 30. No. So this condition do not satisfy. So this statement is not executed. Okay. Largest equals to L won't be executed. Okay. Erase this. Okay. Moving on to the next condition. If R is less than size, 4 is obviously less than 5, right? And now we'll check ARR of whether ARR of right, which is 4, is greater than ARR of largest. Largest is 1, right? So let's check for this. Okay. So this is ARR of 4 is 36, whether 36 is greater than ARR of 1, which is 30. Yeah. So this condition is true, right? So now what happens? Largest becomes R. So largest becomes R. R is 4, right? So largest becomes 4 now. Okay. So moving on to the final condition, the value of largest is not equal to I, right? I is 1 and largest is now 4. Okay. So largest is not equal to I. So what we'll do, we'll swap ARR of I, which is 1, with the ARR of largest, ARR of 4. Okay. We'll swap these two values. Okay. Let's see in the array itself. ARR of 1 with ARR of 4. Okay. So 30 goes to the index 4 and 36 comes to the index 1. Okay. So let's erase. Okay. Okay. So 36 come to the index 1. Okay. 30 goes to the index 4. Okay. Now again, erase all of this. Okay. Let's erase all this. Now the largest is 4. Okay. We will call the now this function is called, which is max-heapify of largest. Largest is 4, right? Max-heapify of 4. Now when we call this function, okay, this third calling, okay, what happens is left becomes 2 into I plus 1. Okay. Right becomes 2 into I plus 2. Okay. I plus 2. Okay. Both of which 2 into I plus 1 will be 2 into 4 plus 1, which is 9, and 2 into I plus 1 will become 10. Okay. Both of this are greater than size. Okay. So there will be no change in the value of the largest variable, right? So there will be no change in this variable, and if this variable is not changed, then this last condition is also not executed, and hence the function terminates. Okay. So the final array that we are going to get is this. Okay. This is the final array that we are going to get, and this